We have never seen them directly, yet we know they are there, lurking within dense star clusters, or wandering the dust lanes of the galaxy, where they prey on stars or swallow planets whole.
يوم تبدل الأرض غير الأرض والسماوات وبرزوا لله الواحد القهار.
That makes this the largest single eruption recorded since the Big Bang. Its source: a black hole that may weigh around 10 billion solar masses. But how does a black hole, a creature famous for hiding in the dark, emit this much energy? Well, think of a black hole as the eye of a cosmic hurricane.
خالدين فيها ما دامت السماوات والأرض إلا ما شاء ربك إن ربك فعال لما يريد.
What's a black hole? Take a mass and compress it very, very prodigiously. As you do so, the gravity of its surface becomes exceedingly strong, and there comes a point where it's so strong that not even light can escape. So a good way to think about a black hole is it's a region where space itself is falling inside the black hole. There's a place, the event horizon, where space falls faster than light. Imagine that this were a black hole. Inside the black hole, inside the event horizon, you can imagine light trying to get out, pointed outwards, trying to get out. But space itself is falling faster than light and drags light itself inside the black hole. So let's imagine that we fall through the event horizon. That's the place where space is moving faster than light. We fall deeper down inside the black hole, but if it's a rotating black hole, and surely they all do, then the centrifugal force begins to slow us back down again. And deep inside the black hole, there's a place called the inner horizon, where the flow of space slows back down to the speed of light. And at that point, all the light and material that ever fell into the black hole tends to pile up. What actually happens as a result of that, stuff trying to come out, stuff falling in, undergoes a tremendous collision and generates this maelstrom of energy. At a certain moment, as we hit the inner horizon, there's this infinitely bright, blinding flash of light. That's what the stuff that's been waiting there, trying to get out, is just held there at the inner horizon.
سبحان الله الحمد لله الله أكبر.
They proposed that the center of each early gas cloud could have collapsed to form a giant black hole. The black hole would immediately start feeding on the gas around it, creating a brilliant quasar. Silk realized that the energy from this newly formed quasar would create intense temperature changes in the surrounding gas. This would cause the gas around the black hole and its newly formed quasar to condense into stars. Which means, in effect, that the black hole could have helped to trigger the birth of the galaxy.
We think of black holes normally as being destructive influences on their surroundings. In this case, they're creative. They're having a very positive impact on the formation of the galaxies.
But there was more. This theory predicted when and why the black hole would eventually stop feeding and go quiet. They calculated that this would happen when the feeding black hole grew so large that the vast amount of energy spewing from its bright quasar would literally force the rest of the galaxy out of its reach.
Has the effect of pushing in a wind against the surrounding gas and driving the surrounding gas away like a snowplow.
With only its hot, whirling quasar within its reach, the black hole would swallow that up and then stop feeding. It would be left invisible at the center of the galaxy.